Welcome, everyone. Please keep your comments going in the chat. We will open the mic up after the presentations for the feedback session. I'm going to give you a quick introduction to COMET before we get into the community presentations for today. So for those of you that are new to COMET, we are at the core a community of stakeholders from a really diverse settings. The last time I checked, we've been engaging with individuals from over 200 organizations, and that ranges really from research performing organizations, organizations that are archiving, publishing, preserving in some kind of way, disseminating, sharing, research of all different kinds. And although we come from different backgrounds and we have different use cases in mind, we really are united in the shared vision that we have, which is a collective stewardship of trustworthy, high-quality PID metadata. And this really represents a fundamental shift in the responsibility of how metadata is currently looked after in our open infrastructures. And to achieve this bold vision, there is a lot of work to do. And our mission is to establish an evidence-based community enrichment model and the shared tools that are necessary to facilitate action towards that mission. We have put forward a model for this phase of work. And last year, around the middle of last year, we described the COMET model as having these three foundational principles. And since then, every interaction that we've had, every project that we've worked on has really refined and improved the way that we are thinking about our work together. These foundational principles will be very familiar to all of you and will resonate with the open science movement in general. We are focusing our work on being a group that collectively looks after the quality of open metadata. And in doing so, we are producing results that is for the collective benefit of the group. That ranges from the enriched data sets that we're seeing being produced in our enrichment projects, as well as the open models and methods to create those enrichments, but also a focus on transparency then allows us to be able to build up a case of evidence so that our model can be shared and worked on as the community as a whole. We've elaborated on this model by defining 6 key elements of the model. And really these serve as a guideline, but also as a way to evaluate our work together. It informs how we interact as a community, who we partner with, the collaborations that we enter into, but also on a very practical level, it helps us set the tone for our projects and define the expectations and standards that we should work together as a group. I'm not going to go into this model in detail at this time. There is a link there which takes you to an article that we wrote in the middle of last year. But I will say that in both of the community presentations today, you'll see these elements represented. Briefly, for those of you that have not been with us from the beginning, collaborative metadata is, of course, not a new idea or a new approach, but it's something that was reignited at 2 key conferences, the Force 11 conference and the Paris conference on open research. That was then led to a phase where we brought together people in a task force and we hosted a number of listening sessions where we spent the time going through what is necessary, what are the needs of the community, keeping in mind all the different kinds of stakeholders, what is the approach both from a technical level and a governance level. We then got organized and we set up a number of pilot projects to test these different approaches to enrichment and also to target specific fields that are high value and demonstrate that value early on in our projects. And we have completed a number of those projects now, and we can confidently say that the model is showing that it works. We've had good results. And we've now at the phase where we're taking those lessons from our projects and we're putting them into action into our new current phase, which is focused on building the foundations that we need to enable scale and sustainability. We're focused on establishing standards, building the community's capacity, and building the infrastructure that is necessary to link up with the existing open infrastructures and make these enrichments reach the authoritative sources where they should be. In our previous meetings, we've presented results on an individual project-based level. And now with the DataCite enrichment layer becoming a reality, it's quite exciting to take a step back and think about the impact that's being made on a DOI level. So this is just a snap of the impact that we're seeing in DataCite. For the projects that we have completed so far that touch DataCite DOIs, our projects have produced enrichments for around 12.5 million unique DOIs, which is about 10% of DataCite's current corpus. And that breaks down into 6 million raw ID, 6 million DOIs with raw ID matches, 4 million DOIs with resource type improvements. And the archive corpus of 2.5 million has various improvements based on our projects, which focused on matching preprints to their published articles and also affiliations and raw ID improvements. Projects continue. There are projects that we have set up from the beginning as our pilots. The first 3 on the list are those projects that are carried over from that phase. And those are essentially the demonstration projects that continue to show improvement in specific target areas of funding, of passing affiliations for the content type of ETDs, and then again focusing on affiliations, but with a focus on multilingual articles, journal articles. The next 2 projects are led by our community members, Posters.Science, which we'll be discussing today, and eLife's recent Pathways initiative, which we'll be collaborating on. And this is exactly the kind of direction that we should be traveling in. We are now essentially closing off some high use case examples of projects that were organized and set up by the COMET organizing group. But to achieve sustainability, to move into a situation where we're able to scale, we want to see more and more community projects coming up so that we can join and collaborate where it makes sense and focus on making sure that the good work that's already being done in the community can be brought back into the DOI ecosystem. And without further ado, I am going to hand over to Bhavesh to focus on our first community presentation for today. I'll stop sharing and hand over to you, Bhavesh.
Hi everyone. I'm Bhavesh. Thank you so much for having me here and giving me the opportunity to talk about our work called Posters.Science. I'm a researcher at the California Medical Innovations Institute. We are a nonprofit biomedical research organization located in San Diego. And here I lead this division I started called the Fair Data Innovations Hub. And so today I'll start with a brief background about what we do with my team, discuss about scientific posters, since they're the main topic of this work, why they're important and some of the challenges we have identified, discuss about this platform we are building called Posters.Science to address some of these challenges and present some of the collaboration we are planning with COMET. And so starting with some background, what we do with my team is we develop software and standards that help researchers easily prepare and share fair and AI-ready data and other research output, and easily kind of part is really the main thing that led me to starting this work. As a researcher in biomedical research, I found that making data fair or other outcome fair or talking about using PIDs, metadata, and so on were kind of topics that were very new to me and very time consuming on top of the work that was already required from me as a postdoc. So I thought, hey, there needs to be things that are built to make this easier for researcher, and that's how I kind of started doing this. And all of the things we developed is free, open source, and supported by many organizations that I'm listing here. Some of them listed here, actually, not all. And there's currently 8 other people helping with all of that work in my team. As you'll see, there are a lot of software developers because, again, what we try to do is build tools that could be easily used by researchers. So they're really focused on automation, easy to use interfaces, and so on, delivered in a way that doesn't require any coding knowledge or anything to make your data code. And as you'll see today, poster more reusable. And I also have a few AI research scientists. And again, the idea is that we try to use AI, LLM, and other tools to integrate in the platform we are building to make it even easier for the researcher to do what they're supposed to do with their data. And again, today I'll talk specifically about a project related to posters. And so it is estimated that millions of posters are presented annually at different conferences around the world, introducing often early findings and for the first time, typically outside of the research group, even specifically in biomedical research, a poster is really the first thing we'll kind of put out there if we are working on something, even if it's really early and so on. And so you can imagine that if poster were shared more broadly, they could provide a timely source of scientific knowledge. They could enhance collaboration. If they had more visibility, you could see what other people are working on very early and maybe potentially collaborate together. And they could also support funding decisions if you have to make a decision on a funding and you can kind of have a vision on what people are doing very early stage around the world. You could say, hey, they tried this already early and it didn't work, so maybe we should reconsider, or you see some promising development in other project that would lead you to think, hey, this is worth supporting and funding. And so we try to look into, hey, let's see how often posters are shared and where they are available. And when we did that, we really didn't find much work around how commonly posters are shared directly. What we found is a few studies that looked into how often the content of presented in a posters ends up being published as a paper. And there's different ranges across the study, but on average, less than 20% of posters end up being published as a paper. And it takes on average 2 years from poster presentation to the publication of the related paper. And so it's really clear that we cannot rely on paper publication to disseminate all of that valuable knowledge that we have in posters. And so we investigated ourselves to see, again, how are posters shared, how often, and so on. And through our investigation, we found 86 platforms where we could find scientific posters being shared openly. And we could not count posters on all of them because on some of them filtering was not possible by posters only and so on. But on the platform, I think we were able to count on about half of them. We found about 150,000 posters, which was a lot less than what we were expecting. I think those posters were published between 2010 and 2024. So we would have expected several million posters out there, but we only found a fraction. And we also looked at for those posters that were shared how good their metadata was. So we did that analysis on posters shared on Zenodo and Figshare because there were some of the platform with the most amount of poster, and they also have great APIs that makes it easier to do such analysis. And so I'm showing here some of the kind of the percentage of posters in a given platform that have a given metadata. And so those that are mandatory, like title, are available for 100% of the posters. And when they are not available, we could see that their value kind of drop. For instance, on Zenodo, where keywords are not mandatory, only half of the posters have at least one keyword, but on Figshare, where you need at least one keyword to publish, all of them have that. And again, funding information available in 20% or so of the posters. And Zenodo also has structured metadata for conference, unlike Figshare. And when we look at that, we saw that less than half of the poster were providing the name of the conference where they were presented at. When you think that's a very critical metadata for finding a poster, you'd likely filter by a conference or search from based on a conference or something to access a specific posters. And so we kind of started thinking about, hey, why are they not shared very often? Why is the metadata not so good when they are shared and so on? So when I asked about around discuss with my colleague, I found out that there was a lack of awareness. They were like wondering why should they even share poster and how they would even achieve that. I encouraged some of my colleagues to do that, and what I learned from them is they found it to be difficult. They didn't know about Zenodo, or when they were like overwhelmed with all the information they had to enter, specifically in biomedical research. Like posters often have a lot of authors, so they were not really pleased with having to enter all of their info back and so on. And they didn't really see any incentive for all of that time they would spend doing that. Because again, I think manuscript publication is really the key incentive here. And on the other side, we try to look into, hey, let's try to show maybe if posters are shared very often, maybe we could do some nice analysis using them together to make some early discoveries. But what we found is that because they're unstructured, as you may know, posters, everybody has their own kind of design that they go with. It was very difficult actually to run any large scale analysis anyway. So it was really not possible to show an example of, hey, this could be achieved if poster were shared. And so kind of to solve all of those challenges, we thought about a platform called Posters.Science. Uh, so it's an open source and free platform that facilitates the sharing and discovery of fair and AI ready posters. I had this idea, I think, around 2000, yeah, I think 3 years ago, 2023. Not a lot of interest initially, then learned about the navigation fund, and we got a grant from them uh, last last year in September, and we launched actually a first version of the platform just this month. And I guess the first challenge I was hoping to solve with Posters.Science is just with the name, have something where people know, hey, this is something maybe I could go around and share my poster rather than having to be confused about uh, a platform like Zenodo, again, where there's a lot of things that they could do. So have a name, but again, remember and know that this is something I can go to learn about sharing poster, share my poster, but also maybe learn about why I should do that and how and so on. So that was kind of the first idea with the name. The other thing we tried to do is to reduce poster sharing to kind of 3 steps that hopefully are very simple, that anyone could do them without much knowledge about metadata and so on. So the way it's designed right now is when you start sharing a poster, you can upload the PDF of your poster. We have tooling that extract metadata automatically from the posters, and I'll tell you a little bit more in following slides. But we extract the title, generate a description, keywords, author name, their affiliation, whatever we can find in the poster. So the author only has to kind of review them quickly, and then in a final step, select a platform where they want to archive their poster. And another thing we do as they're sharing their poster is that we save that metadata and all the poster info in a poster.json file that also gets shared along with their PDF. And so poster.json is something we kind of developed as a machine actionable version of the poster. Like I told you, posters are very unstructured, and we're hoping with poster.json we can have poster that to a machine at the very least look exactly the same. And so we developed this schema based on the DataCite schema with some poster specific extension we have added, like conference name, location, and so on. And so the idea is that a poster like this, for instance, would look like that as a poster.json version. So it's really a kind of free of any structure and so on. And it will be very consistent across all the posters. And of course, creating this poster.json manually could be difficult. And that's what I was mentioning you, that the platform extract that automatically from a PDF of the file and generate that JSON for the user of Poster.Science. And so we developed something we called poster to JSON that achieves that from a PDF of a poster or even from the image of a poster, combine some existing tools to extract text from the PDF or an image, uses a large language model to generate a JSON. And currently we have manually created 20 poster.json for 20 poster and kind of using them to validate and improve the model. Another thing we're doing is that there's a lot of posters, like I mentioned, that are already out there and shared. So what we're doing with Poster.Science is also creating a registry of all those posters so you can find all of them in one location. And so what we do right now is, for instance, take all the posters from Figshare and Zenodo, check if the record is actually a poster, and I'll tell you a little bit more why we needed to add that step. Run poster to JSON to create a poster .json version of the poster and index it on poster.science. So then if you go into the discovery page of poster.science, you could search, find all of those posters and so on. We also plan to have like an export of all the JSON API access, so you can search poster through API. Where we also plan to add a smart search, something that was suggested to us by kind of people we asked to try that early, which would be basically a way for you to ask a language question in plain language, like, hey, what was presented about the connection between the eye and the brain at the ARVO conference last year, and would generate a summary and show you kind of the top most relevant poster and so on. So kind of making it easier to find and reuse whatever knowledge someone needs from those posters. And I mentioned that we needed to kind of check if those records that were shared as poster were really poster, because we found that a lot of things shared under the poster tag on Zenodo and Figshare are actually not poster, but rather abstract of the poster or some slides and so on. I think we believe from kind of a quick analysis that about 20% of the record shared as poster are not poster. And to kind of help us classify that, we developed something called Poster Sentry, which basically looks at a PDF, uses kind of the text in the PDF, visual layout, and so on to classify the PDF as a poster or not a poster. And currently, the way we've trained the model is we've used uh, everything that's shared as a poster is a PDF and one page. We said, and it's of a certain size. We said that must be a poster, and everything else is not a poster. And that's how we kind of creating a training set. And I'll mention to you how we could improve that training set to improve the performance of Poster Sentry to identify a poster accurately. And I guess that leads me to kind of the few final items, which is collaboration with COMET. Like I was just mentioning, we discussed a few things that we could achieve with the COMET team and the COMET community. One of them is to improve poster Sentry. Like I said, right now we kind of created a data set a little bit on the go. So all of that effort, by the way, about poster Sentry, poster to JSON, and so on, and the way we kind of are building it is not part of the original funding that we currently have. The funding is really to build the platform, use Llama or something really quickly, and kind of let people share poster as a way to put the platform out. So the phase one funding that we have was really support to kind of just launch the platform and kind of maybe in the future look or more into that. But I guess as we were working on it, we felt that it might be maybe more suitable to start those on the side anyway. But the way the survey is designed is that you can go on, it's completely anonymous. When you start, you get assigned an ID. And when you start the survey, what you'll have is you'll see a bunch of images. And all you'll have to do is to click yes or no to let us know if it's a poster or not. And so for this one, I'll say no. It looks like probably a slide. This looks like a poster, so I could say yes and so on. And if you can do 100 of those, we think it will take about 10 minutes. That would be really useful to us. So we then use the data from kind of human curated data set to retrain and improve or potentially the performance of Poster Sentry. Another thing we developed with the COMET team is to improve and better validate poster to JSON. So see how we can extract better metadata. We also are thinking about secondary metadata that's not into the poster. For instance, maybe we could integrate into poster to JSON with ORC ID, ROR ID, and so on. So we could also add those into the metadata for the author to review. And hopefully they'll submit that as well when they publish those on Zenodo and Figshare or any other platform where they share their poster. And again, given the goal of COMET and the way the process is designed, what we would like to do eventually is once we have those tools better, more improved, better validated, is to use those to improve or enrich DataCite record of posters. So you can imagine with Posters entry, we could go back, and I told you we think there's about 20% of things that are registered at poster that are not posters. So maybe we could use those to address that. Uh, and I also mentioned that there's a lot of poster out there, but that have very little metadata. So maybe we could use poster to JSON to kind of improve the metadata of those poster, add keywords, funding information, ORC IDs, and so on for those posters. So hopefully we can have an impact with this project that we didn't think initially. So kind of to correct and improve record at scale. And closing comments, again, we look forward to working with the COMET community. If you could do the survey already or provide feedback on Poster.Science, that would be great. And on the kind of the sad side is that so the navigation fund is designed to fund in multiple phases. When in phase one, they provide a little funding to get started, and if they like more funding later on. But it turns out they're closing their open science program. So we are looking for funding if we want to keep this work going after August of this year. So if you have any knowledge of any thing that would fund such a work in my field, I mostly get grants from the NIH, the National Institute of Health, and this is not really their kind of sort of project that they're interested in. So if you know of anything, please let me know. That'd be great. And with that, I'd like to thank again the organizer, Dion, Adam. They have been wonderful in helping me set this up, and thank all of you for listening. Yeah, thank you.
Thank you, Bhavesh. And Adam has shared the link to the survey in the chat. Please participate and share with others who you think might be able to. I'm going to hand over to Cody in a moment for the presentation from the DataCite team. But also I wanted to give a thanks to the Navigation Fund because they have also funded the work that Cody is about to present. So thank you to the Navigation Fund. And over to you, Cody.
Great, thanks. It's really exciting to see this, Bhavesh. I feel like I remember talking about these mappings from DataCite or something. I can't even remember if I was talking to you directly or not, but it's nice to see all of this outcome. And yes, of course, thanks Diony and Adam and Comet for having us. Yeah, I'm excited to talk about some of the enrichments developments over at DataCite, largely in collaboration with Comet. My name is Cody Ross. I'm a product manager at DataCite. Many on this call may have some familiarity with DataCite, but to briefly introduce what we are and what we do, DataCite is a community and an infrastructure provider that supports over 1,700 research organizations in making research outputs and activities both more visible and discoverable. Research organizations can register DOIs and share metadata using the DataCite metadata schema to drive reuse and impact of their research outputs and activities. And with support for over 30 resource types, including newly posters and presentations in Schema 4.7, the schema facilitates citation, identification, and connections to people, organizations, other resources, and more. So historically, DataCite metadata has followed a fairly straightforward journey. The journey starts with research organizations who register DOIs with DataCite and share metadata with us. These organizations include universities and colleges, libraries, archives and museums, research institutions, funders, and more from over 60 countries. And their sources for metadata are varied, including data repositories, institutional repositories, preprint servers, and other organizational platforms containing the local metadata for the many research outputs and activities we support, from software to awards to, of course, newly posters as well. metadata is sent in to the DataCite, sent in the DataCite metadata schema, and then is stored and processed in the DataCite metadata store, which makes it possible for research organizations to reuse the metadata through harvesting to power discovery services, research information systems, national catalogs, and more that rely on DataCite for a centralized source of trusted, high-quality metadata. And so for almost 2 decades, the DataCite metadata store has grown into a rich and valuable source of information and insights that reflects the depth and breadth of global research activities and powers discovery, reuse, and integration across the research infrastructure ecosystem. I believe there's now 125 million DOIs now registered with DataCite. So why pursue enrichments? As the DataCite metadata store grows and as downstream metadata systems and services increasingly rely on this metadata, demands rise for both discovery and reuse. Likewise, expectations grow for DataCite services and infrastructure to make high-quality metadata registration and retrieval as easy and effective as possible. Through some internal analyses and community consultation, we've identified some broad categories of challenges that our community has in facing in creating, managing, and maintaining high-quality metadata at this scale. These include keeping records up to date as the DataCite metadata schema evolves, adding new resource types, new ways of connecting metadata, ensuring metadata fields and properties are used consistently across the metadata store so they can be harvested and interpreted accurately, contributing all the metadata that's available locally at an institution to DataCite, sometimes with third-party integrations as an obstacle, managing gaps in metadata stewardship as critical personnel leave or change roles, and bridging fragmented siloed metadata sources across the research lifecycle. I'll pause for some water. I had a bit of a cough last week and it's persisting, so apologies if I cough. So while DataCite metadata has a significant amount of value already as an open data source of outputs and activities, as well as their connections to people, organizations, resources, and more, optimizing the richness and usability of DataCite metadata continues to be a longstanding goal in service of DataCite's mission. And to meet the aforementioned challenges and this high-level goal, we're working alongside the community in an ongoing multifaceted effort to improve the quality and utility of the DataCite metadata store. And enrichments are a really exciting new tool in this effort, providing a new avenue in the metadata journey wherein downstream community-sourced enhancements can be pulled back upstream and into the DataCite metadata store. Enrichments allow us to harness downstream metadata contributions to complement the submissions of original depositors, support original depositors with naming, describing, identifying, and connecting their resources, and ultimately enhance research, discovery, reuse, and reporting across the research ecosystem by improving the quality and precision of DOI metadata. And COMET and the COMET community, of course, are integral partners in executing on these really key goals. So we're excited to share some updates on how this enrichment ecosystem looks in practice from DataCite's end today. So first, we'll zoom in to DataCite's enrichment data model, which captures some of the higher level goals around connection and trust at a granular level. The data model for an individual enrichment has 3 core pieces of information: the DOI on which the enrichment is asserting a change, the provenance of the enrichment, and the enrichment action, or what changes the enrichment asserts to the DOI's original metadata. In many ways, the data model reflects DataCite and COMET's principles, strategy, and approach to enrichments, relying on existing community metadata patterns to build in indicators of transparency, traceability, and credibility into every record. For instance, the provenance fields of the enrichment data model include the contributors of an enrichment and the resources associated with an enrichment, such as project documentation and related data sets. The structure of both of these fields are borrowed directly from the DataCite metadata schema and allow anyone examining an enrichment to discover who created the enrichment and investigate how it was generated, similar to how one might examine a DataCite DOI record with this connection metadata. We've developed this data model alongside COMET and the DataCite community, and the model forms the basis of a JSON-formatted enrichment records, which COMET has been creating an output of their enrichment projects and then delivering to DataCite for processing and storage in our systems. So zooming out a bit from the enrichment data model and enrichment records, we can look at the current state of our enrichment ingest and access workflow, which sets the stage for our demo in a bit. On the left, COMET conducts enrichment projects, discussed earlier by Diony, which produce, among other outputs, a data file of JSON enrichment records formatted according to the DataCite enrichment data model and transport format. DataCite then ingests these data files, checking each record for several indicators of validity, including whether the record is structured as expected, whether the record contains key provenance metadata, if the enrichment record is still relevant to the original DOI record in our systems, or in other words, if the original metadata targeted by the enrichment has changed since the enrichment record was created, and if the enrichment, when applied to the original DOI record, produces a DataCite DOI record that's valid under the DataCite metadata schema. So if the enrichment record passes these checks, then we store it in our enrichment data store, which is accessible to anyone via a new enrichments endpoint of the DataCite REST API. The original DOI record is stored separately and is unchanged by the aforementioned processes or any that come next. This original record is strictly under the control of the original depositor. Users can access the original DOI record at any time through DataCite's existing APIs, like the REST API, as they always have. However, if a user requests an enriched DOI record, the enrichment records for that DOI are pulled from the enrichment data store and applied to the original DataCite DOI record, producing a separate enriched DOI record that is then returned to the user. The process of applying enrichments is responsive to changes in the original record and prioritizes metadata validity. For example, just as in the during the ingest procedure, enrichment records are not applied if targeted metadata fields are updated by the original depositor, and the original DO record is displayed in place of the enriched record if the enriched record is in any way invalid according to the DataCite metadata schema. So for context, here are some numbers to reflect the current state of enrichments ingested into DataCite systems via COMET. So this is sort of reflecting what Diony was talking about earlier, but we haven't ingested every single record that's been produced so far. But as of yet, we've ingested 26.9 million enrichment records derived from two of the COMET enrichment projects that Diony mentioned earlier. The first linking archive preprints to their published versions, creating 855,000 new connections between previously unlinked resources, and the second, which maps affiliation strings to research organization identifiers, establishing 26.1 million new connections between resource creators and contributors and their ROR ID affiliations. And in combination, these two projects enrich over 6.3 million unique DOI records, and we're really looking forward to ingesting additional project and records as development continues and as the collaboration continues as well. So to bring all this information together, we've planned a quick demo where we'll take a closer look at real ingested enrichment records stored in DataCite's enrichment store and explore how they can be used to investigate the provenance of an individual enrichment. And then we'll take a look at an enriched DataCite DOI record to see how enrichments might benefit discoverability and impact by expanding the outward connections of a given resource. So this might involve some just looking at JSON records, but we'll end with a little bit more of hopefully a visual representation of what we're doing. So yeah, bear with me as I kind of go through what we've done. So as I mentioned earlier, all of the enrichments that DataCite has ingested from COMET are available via the DataCite REST API at the new enrichments endpoint. You can see the URL for that at the top of the screen. I can also drop it into the chat in a bit. The endpoints list every enrichment that we've ingested in JSON format according to the enrichment data model. And so, for example, you can see that the first enrichment record targets this DOI. Let's see, DOI field is here, and is contributed by COMET and was derived from this linked data set here. And you can also see that it updates a creator in the creators field at the DOI metadata according to the enrichment action that's described within the field action original value and enriched value fields of the enrichment record. We can also filter the results of the enrichments endpoint by DOI or by repository ID. So in this case, we're using the DOI filter to view all of the enrichments targeting a specific archive DOI. You can also see that DOI that's in the URL here. Okay. Each enrichment comes with the expected target DOI, provenance metadata, and enrichment action attributes. The first four records appear here. They describe updates to individual creators in the metadata, connecting their affiliations to ROR IDs. And the last record in the list, which is number 4, describes updates to individual creators. While the last record is derived from COMET's archive preprint matching project and has a resource that links to a DataCite project DOI. And if we resolve the DOI and view its landing page, which is here in the resources section of the provenance metadata of the enrichment record, we can see more information about that project furnished and maintained by COMET. And I'll briefly let Dione explain what's here.
Sure. So these project documents or project hubs were originally conceived as a lightweight way to get the community's input on ongoing projects and also to publicly, openly share all of the information around the enrichment projects. But we soon realized that as we were creating them, they could also serve the purpose as a permanent record of the project. And we could link that record of the project to each enrichment made. So we decided to give the project documentation a DOI and to ensure that the documentation is a record of everyone involved in the project, the methodology of the project. It gave a kind of overview of the timeline, considering it was current if people wanted to follow it. And it links to all of the resources produced from the project, including the models, the data sets, any other events that happened around it. And then the assessment that we did as a group following the project. So it was a light way in the beginning to share project documentation, but then we then decided to go down this road of providing the full record. And we'd really like to get community feedback on this, maybe in the discussion later, or in another forum, because this was one idea and it should be improved and expanded upon with community input. The last thing I wanted to mention on this is, of course, because it has a DOI, we've also then included the names of all of the contributors that were involved in this project, and that's then coming through in the DOI connected to this. Thanks.
Great, thanks, Yoni. So now that we've explored several enrichment records and investigated how one was generated, we can turn to an enriched DOI record, which gathers these enrichment records together and applies them non-destructively to the original DOI record. These can be previewed for individual DOI records with enrichments using a new enriched equals true flag in the DataCite REST API. So for the archive DOI that we were looking at, enrichments about earlier, we can view the original record here, and then by adding the enriched equals true flag, we can view the enriched DOI record. So scrolling through, we can see that there have been some changes. And then if we go all the way to the bottom of the record, we can see a list of the enrichment records that have been applied to that DOI to generate the enriched DOI record. So just quickly switching over to a diff view of that to make this a little more clear. We can see several enhancements to the metadata, the addition of ROR IDs to affiliation metadata in the creators, connecting the creators to their affiliations with a ROR PID, and the addition of a new related identifier, which connects the preprint with its corresponding published journal article DOI. So the result is a metadata record that's more discoverable, more connected, and easier to use for downstream use cases like institutional reporting and funded reporting, bibliometrics, and more. So This is where we are now. We spent some time establishing and refining the enrichment data model. We've been prototyping approaches to generating enriched DataCite DOI records. We've been ingesting available enrichment records provided by COMET and then making them available via our APIs. And we're now able to demonstrate enriched DataCite DOI metadata records by applying ingested enrichments to original records. And next, we plan to ingest more of these enrichments produced by COMET, both updates to existing projects and new projects, and expand access to enriched DataCite DOI records based on community access needs. And as we continue work on enrichments this year, we also plan to develop enrichment curation tools alongside the DataCite membership and metadata creator communities, further iterate on the enrichment data model based on feedback from COMET and the greater metadata curator communities, and further integrate enrichments and enriched metadata into DataCite services. Of course, we love the COMET community's feedback on our current activities. Feedback and collaboration is core to our product development processes, so we invite you to take a look at our latest update on our enrichments work and participate in our new enrichment survey. And I think those will be linked in the chat for you. And that's all I have today. So yeah, looking forward to the discussion. Thank you for the time.
Thank you very much, Cody. I have enabled everyone to unmute their mics and we can go straight into the discussion. We have a bit less time than we anticipated. So I'm really just going to open it to the floor to see who has questions. Please unmute yourself and feel free to turn on your mic and we'll try to field as many questions or comments as we can, the time we have left. Gretchen.
Hi, yeah, I asked that question in the chat. I just want to make sure I understand. So someone creates an enriched record, you send it to DataCite, you check that it is valid, matches the DataCite schema, and then you store it as an enriched record. And if I'm just Joe user looking at records, I don't know that that enriched record exists. The only way to access it is to put in the API enriched equals true, and then I see it if it exists. Is that correct? Is there a plan to kind of make those records more visible if that is the way it works?
So I can answer that question, if that's right. Right, we receive these enrichment records which describe improvements to individual fields within the DataCite metadata schema for a given DOI. We store those and then we create these enriched DOI records that we are now sort of previewing. It's just, we're only displaying these for individual records that are retrieved. And the idea, yes, is to expand access to these enrichments on a grander scale. Based on community feedback that we're sort of actively gathering right now based on this preview. So I think, that's the right idea, Gretchen.
Okay, thank you.
Questions or comments from anyone else?
Sorry if I missed that, but I was wondering, do we track in the enrichment who enriched it, when, and all of those provenance things?
Yes, Cody, I can answer if you like.
Sure, and I can expand if you like afterwards.
Sure. So the name of the organization or person who created the enrichment is tracked as part of the enrichment record. And it also links to further documentation around that. Cody, maybe the best thing to do is to get feedback on the issue itself. I will pop that into the chat, but that also gives the same example demo that you walked through. It shows the provenance layout, right?
Yes, exactly. Slightly different DOI, but similar process.
Okay. Raina, excuse me if I'm pronouncing that incorrectly. You've raised your hand.
Yes, thank you. It's Raina. First of all, I want to say this has been excellent work, excellent progress to see. I'm really glad to see this progress being made. It's so needed. But then now that I see maybe this is on the horizon, but I just wanted to understand that a bit better in terms of how other projects or also users who want to like their systems or actual individuals want to apply, like say their data usage information, like say they reused the data set and they want to say in what way they used it with a reference to their journal article or whatever it happens to be. Is that some of the enrichment curation tools that we can imagine coming on the horizon? And if so, how far away do you think we are from that ability to do that?
So if I'm understanding correctly, it's the question is sort of, if I want to assert something about a DataCite DOI record and, but I'm not COMET or I'm, maybe, don't have this institutional connection yet,
Yes.
how would I be able to do that? Yes, okay. So I think this is the ultimate goal is to be able to support these kinds of community sourced enrichment records and to, really gather the community around improving the data, the metadata store so that it's, as usable as it possibly can be. It's not something that it's something we are just actively exploring, as we continue development on this. So more to come.
Well, maybe I'll just say quickly then, like what the use case I'm thinking about is the recent work that I've been involved in with the Force 11 data usage typologies that just recently came out, and in thinking about how that can actually come to fruition rather than, again, being a burden on the original minters of the records, that it would be great if the users or the systems where the users are publishing their secondary outputs or derived outputs, if they could do that update themselves. And so that's what I would really love to see. Yeah.
No, that's really great feedback. Yeah, thank you. And the use case is really helpful to understand as well.
I think we have time for one or two more questions before we wrap up. If anyone wants to raise your hand or open your mic. Ted.
Deanna, this is Ted Haberman.
Yes.
I had a question earlier for Bhavesh, or sort of a general question for everybody. Right now, DataCite has over 30 resource types, quite a broad selection of things that you can document and get DOIs for in DataCite metadata, and it's a wonderful thing. And of course, the same thing is actually true for Crossref. They have a lot more detail in sort of article types and things like that, reflecting their early history. But one of the things that I've noticed when I'm talking to people about identifiers is when you give them choice, that increases confusion. So, many people in many meetings that I've been in say, well, should I use this or should I use this? Or should I use this? Or what is this? And who's this? And what's this? And so as we build systems like Posters.Science or DMP tool or other thing, Braid is another one, we're creating nice custom systems. And like Bhavesh said in his slide, said, oh, this is really the DataCite metadata with extensions. And that's a current model. And we all say, oh, that's wonderful. But I think that it's hard to understand how much confusion that causes and what the adoption cost of that confusion actually is, because what this does is it slows down the adoption of identifiers for everything, because people only need a small amount of confusion before they don't move forward, right? So anyway, I think should we have 35 different things or should we have one different thing? Or I think that we really need to think about that when we look at tools for posters or tools for computational notebooks or tools for whatever your favorite resource type of the day is. And the end point of this is a separate system for every, and maybe in some cases even a separate identifier for every one of those resource types. And in my opinion, that's a negative effect.
Maybe I can mention something about the Poster.Science side of things. Is actually not, the user won't even know there's a DOI or what identifier is and so on. Again, in my field, at least, most people don't even know you can have DOI outside of papers. And so the idea is they won't know that. We integrate with Zenodo, use the DataCite schema to the extent where we could find things from Poster, we could record from that. The extensions was also mainly because we thought, hey, conference is important for Poster and we would like to have it in a Poster.json, but there's no necessarily a place for that in the current schema. But we did work, and we will continue to work with DataCite, I think, to align those as much as possible. But yeah, I think on the Poster.Science, I think the user won't know much about all of those technical aspects of it. And that was my idea, is that not to overwhelm them with any of that. All they'll know is the poster is here, here's my title, author info, all automatically, and I'll push it on a platform called Zenodo because I'm told it's great for Poster. It's kind of the idea.
Thank you, Bhavesh. We are out of time. I'm going to take just 2 minutes of everyone else's time. If you can stay, please do. I just wanted to quickly run through how you can get more involved and share information about our next meeting. Everyone can see my slides, right? Great. Okay. So the fact that you're joining this meeting, I wanted to say thank you very much. I realize everyone has busy schedules, but it's really an important opportunity for us to raise these discussions and have an opportunity to talk about them in this forum. So thank you. If you want to get more involved besides these meetings, we would really like to showcase any enrichment projects that you might be working on. Just as we've done today, we've showcased Posters.Science, and we have demonstrated how it aligns with the goals of the COMET model and how it's leading to a project where we can take in the value. We would like to do that for any other project that's on the go. And so please reach out and share any projects that you might be working on. We will also be, over the next couple of months, publishing drafts of standards or guidelines that are based on the work that we've done together, that are based on the lessons from our projects, so that we can improve the work and get community input. For example, the project document, which I showed earlier, that's just one example of a provenance document that travels with the record. If we could consider that a permanent thing, then is it covering everything that it should? What's missing? And those are the kinds of things that we would like to get the community's input on. Of course, there's projects on the go and more projects that could happen. Please do reach out if you have ideas around that. And of course, there's always opportunities for any other kind of support, whether that is in-kind or financial support. And you can head to our Join Us page on our website, or just send us an email. There's a newsletter there to sign up as well. And I just wanted to share the link or the QR code for our next community meeting, which will be happening on the 14th of July. So please go ahead and save that and share it wider. And we hope that we will see you next time.